Example 5.19. The ammonium ion is a polyatomic ion with a positive charge. There's 1 nitrogen, 4 hydrogens, and the net charge of this polyatomic ion is positive. Well, let's figure out how many valence electrons are available. Well, in this compound, we have 1 nitrogen atom, 4 hydrogen atoms, and 1 positive charge. So here's how you deal with this. First of all, I'm going to take a look at a periodic table to determine the number of valence electrons that nitrogen and hydrogen have. On the periodic table, nitrogen is in group 5A, has 5 valence electrons. Hydrogen is in group 1A, has 1 valence electron. Using the simplified periodic table, you see that nitrogen is in, again, group 5A, 5 valence electrons, so each nitrogen has 5 valence electrons, and each hydrogen has 1 valence electron. So this means that since there's only 1 nitrogen, it's bringing 5 valence electrons, but each of the 4 hydrogens bring 1 valence electron. And then what I'm going to do, I'm going to subtract 1 valence electron from my total here because the ion has a net positive charge. So I am going to go 1 times minus 1. 5, 4 minus 1 is 8. There are 8 valence electrons in this ion. I'm going to put the nitrogen down as the central element, and I'm going to put the 4 hydrogens down around the central element. Next, I'm going to connect the central element to the outside elements with a single bond representing the sharing of a pair of electrons. Now I'm going to put the electron dots on this bond. Starting here, this line, which represents a chemical covalent bond, will have 2 electrons. And the same for all of the other single bonds in this polyatomic ion. Well, now I have to determine if all the atoms are happy. The hydrogens on the outside each see 2 valence electrons, and they're happy. They obey the duet rule. Hydrogen only wants to have a total of 2 valence electrons because the outermost electron in hydrogen is in the first energy level, and the first energy level can only accommodate a maximum of 2 electrons. Nitrogen, on the other hand, obeys the octet rule. It can have 8 valence electrons around it, and how many does it see? 2, 4, 6, 8. Well, this Lewis electron dot diagram has 8 electrons around it, 8 valence electrons around it. We had 8 valence electrons to distribute. So far, so good. The only problem is we have to indicate that in order to draw this happy Lewis electron dot diagram with the right number of valence electrons, we had to take 1 electron away from the tally. So to do that, what we need to do is draw square brackets around the ion and put the charge in the top right-hand corner. Now the charge in this case is plus, or +1. And that's it. This is probably the only positively charged polyatomic ion you will see in this level of chemistry. So